All right, here's an example that deals with vectors in 3 dimensions. I'm given 2 points, A and B, and we're working in 3 dimensions, so we have x, y, and z coordinates. And we want to find AB, the vector that starts at A and goes to B. We want to find vector BA, so the vector that starts from B and goes to A. We want to find the magnitude of that vector. And we also want to find the midpoint, the coordinates of the midpoint of vector AB. Okay, so first of all, we want to find vector AB. AB, again, is the vector that starts at A and goes to B. It starts at A and goes to B. Starts at A, ends at B. So I can write vector AB in component form by taking the x-coordinate of the B point, 3, and subtracting the x-coordinate of the starting point, -1. So 3 minus -1 is going to be my x-component of this vector. My y-component, I want the y-coordinate of B, which is 2. And I'm going to subtract the y-coordinate of A, which is 0. Then for z, I'm going to take the z-coordinate of B, which is -1, and subtract the z-coordinate of A, which is 7. Alright, so these are the coordinates of the point where I'm ending, minus the coordinates of the point where I began. So in component form, vector AB is going to be 3 minus -1, or 4, 2 minus 0, and -8. Alright, so there is vector AB from part A. For part B, I can use the fact that the vector that goes from A to B is equal to -1 times the vector that goes from B to A, and vice versa. So vector BA is just going to be -1 times vector AB, 4 to -8, which would be -4, 2, and +8. Alright, so these are the two vectors, vector A and vector B. For part C, I want to find the magnitude of vector AB, okay, and that's going to be equal to the magnitude of vector BA because they're both the same length. I'm just going to use this one, vector AB, right here to find the magnitude. So to find the magnitude, I want to use the distance formula, which is going to give me the distance between points A and B. And that is that 3-dimensional looking Pythagorean theorem thing. So I'm going to have 4 squared plus 2 squared plus -8 squared, and I'm going to add those squares and take the square root, and that is going to be my distance from A to B, which is the length of vector AB. Alright, so it would be 16 plus 4 plus 64 should be 20 plus 64, so square root of 84, which should be 2 times the square root of 21, I believe. Okay, so this is the magnitude of vector AB, which is the distance between point A and point B. Alright, the last thing I want to find is the midpoint. I want to find the midpoint of the vector that starts at A and goes to B. And to do that, I just want to find the middle of the x's, the middle of the y's, and the middle of the z's. So midpoints are pretty easy to find using this midpoint formula. Okay, so I want the midpoint, I'm going to call it M. The coordinates of the midpoint are going to be, for the x, it's going to be 3 plus -1 divided by 2. For the y, it's going to be 2 plus 0 divided by 2. And for the z, it's going to be -1 plus 7 divided by 2. Right? So the midpoint of vector AB, it's just going to be, the x-coordinate of the midpoint is going to be the average of the x's for A and B. The y-coordinate for the midpoint is going to be the average of the y's, and so on for the z's. So this is going to be 3 minus 1 over 2, so 2 over 2, 2 over 2, and 6 over 2, or 1, 1, 3, are the coordinates of the midpoint of vector AB.